All right, today we are going to be talking about rounding and estimating. This is from the 5A textbook, specifically pages 25 through 29. A few things we're going to cover. We're going to be covering just basic rounding. We're going to be talking about estimation, which is pretty straightforward in most regards, except when it comes to division. And then we'll also be talking about front-end estimation, just so you'll be familiar with it. But let's go ahead and get started. So again, we're going to go to our notes. Today is the 28th. And we are talking about rounding and estimating. Now, it's been a little while since we've taken notes. So just as a refresher, you're going to want to either skip a line, or if you're out of room, go to the next page. Go ahead and put the date and the header, right? That's what we're talking about. And again, the reason we do this is when you go back into your notes and are looking like, oh man, I'm studying for this test or this quiz, and I don't remember how to do this type of problem. You can look back and be like, oh yeah, I know what that is. Here's an example of that. So, anyways, let's just start with rounding. We don't necessarily need to define it, but rounding is just essentially simplifying or going to a number, usually in its highest place value or in a specific place value that they're asking for. And just everything behind it goes to 0, right? So it's like, what is this closest to, based in thousands or tens or 100,000s. Okay. What I want to write down, though, are some rounding rules, right? Because we're either told to round up or round down. And there's a nice little rhyme that we're going to write down. Many of you might have heard it before, that helps us know how to round. So the first thing you need to do is look to the place value to the right of the digit you are rounding, right? So although if it says, hey, you're rounding to the nearest thousands place, we need to look to the right, to the hundreds place, to determine which way we go. Okay. Now, if that number on the right is 5 or more, we round up, right? And the way to remember that, 5 or more, we raise the score. And so when you see that in a problem, it might be like, all right, it's 2,700, round to the nearest thousands. Well, we look at that 2, and we need to determine, is in the hundreds place a number that's 5 or bigger? If so, we need to turn that 2 into a 3. And then everything behind it turns to 0, right? And that is a bigger number, right? 3,000, we've rounded up to 3,000. 3,000 is bigger than 2,700. Okay. Next, if it's not 5 or more, if it's 4 or less, we let it rest. Okay. And what that means is if it was like 2,400, right, we wouldn't round it up to a 3,000 like we did with our previous example. We would round down. All right, but it says let it rest because here's the deal. Rounding down doesn't mean we turn that 2 into a 1. That'd be going too far, right? We're taking that 2 and everything behind it is going to 0, right? So now our number is 2,000, right, which is less than 2,400, hence the down, right? Hence the rounding down. So that's what that means. Okay, so let me go ahead and show us our first set of notes. Feel free to pause so you can get these written down. And then in a moment, I'm going to show us some examples of this. All right, so let's say in our example, or we'll do 2 different numbers. We'll say round to the nearest 10,000. All right, so example A, let's say we have 14,715. Said to the nearest 10,000. All right, so there's our number. 1 is in the 10,000s place. Okay, so that's the place we're rounding. We need to look to the right of that. That's the thousands place. And behind there is a 4. All right, so what we need to decide is, do we leave this as a 1 and everything behind it goes to a 0? Or do we bump it up to a 2 and everything behind it goes to a 0? Well, looking to that number, it's a 4. 4 or less, let it rest. It's going to stay as a 1, and everything behind it is going to go turn into a 0, right? So this number is closer to 10,000 than it is to 20,000. All right, let's do another one. Let's say we have 398,411. Okay, so there's our next number. And right there in the 10,000s place is a 9. Now behind it is an 8, right? To the right of it is an 8. 5 or more, raise the score. All right, so our options are leave it as a 9 or bump it up to a 10, which we'll see how that affects it as well. Since it's an 8 that's to the right of it, that is a 5 or more, raise the score, like I said. So we're going to bump it up. Now, the way I think of this, I almost want to think of these two digits the same, right, of that, or together, right? That's a 39 instead of just the 9 on its own. So we're going to bump up one more than 39 is actually going to give us 40. And then the rest are going to be zeros behind it. So in that case, we rounded up. All right, so make sure to get this example into your notes. Okay. Now, this does, like a lot of students ask, well, what's the point of this? I'm not really getting an answer. I'm rounding it, yes, but to what end? All right, what is the purpose, right? And so that's when we're going to get into our second section, which is estimation. All right, estimating. Estimation is a way for us to kind of guess or make an educated guess about what the answer is going to be before we solve. So we know, all right, here's where I should be going. Or you can use it at the end to check, I've solved the problem. Let me estimate the answer. Was my answer reasonable, or did I mess something up in between? Did I multiply wrong? Did I subtract wrong? Something. All right. These are pretty simple. Adding with estimation, subtracting, and even multiplying with estimation is actually relatively easy because it's almost going to lend itself to mental math. You're usually going to round to the highest place value and just add or subtract and make sure the zeros are there. Division is the one that is kind of odd. So let's talk about the first few, and then we'll get into division. When we're just doing normal estimation, we're just going to round and solve the problem, all right? And that'll give us our estimate. So for example, if I had 4,285 plus 2,763, if I was going to estimate, we're going to round to the highest place value. 4,285, well, that's 4,000 rounded. And 2,763, that rounds to 3,000. So that gives us about 7,000. That's what we estimate. Our answer, if we solved this, actually would be about 7,000. Now, if we actually solved this, we would add those up. 3 plus 5 is 8. 6 plus 8 is 14. 7 plus 2 is 9. Plus 1 is 10. And then 1 plus 4 plus 2 is 7. The actual answer is 7,048. So I would say that's a relatively close estimate. Okay? And the same works with subtraction. Multiplication, a lot of the problems we're going to look at, you're going to have one number you'll need to round, and then you'll just multiply it by the other number. So you might have 8,912 times 6. So we'll round that 8,000 and then just multiply by 6. And that will get us our answer, or at least our estimate, I should say. So those work normally. It's when we get to division that it gets weird, because if you round in division and you just use the normal rounding rules, you might not always have, or you might end up with a remainder, right? And the point of an estimate is supposed to be quick mental math. You're just checking something. And so, there's going to be some different rules to make that a little bit easier. So I'm going to write when rounding, for division, round to the nearest multiple. Okay, round to the nearest multiple. What that means is, let's say I'm dividing by, 8. I want to round the other number so it's 8, 16, 24, 32, 40, 48, 56, etc. All right, or if I'm rounding and I'm dividing by 5, I want it to be, 5, 10, 15, 20. I want that beginning part because then it'll be easier to divide. It might not be necessarily the most accurate estimate, but we're not necessarily going for accuracy or perfect accuracy, that is, in estimation. So let's say I have a division problem that is, 4,128 divided by 7. Okay, 4,128 divided by 7. Now, looking at that, if we just rounded normally to the nearest thousands place, that would just be 4,000. Or if we rounded to the nearest hundreds place, it'd be 4,100. Well, if we looked at those digits on their own, can 7 go in to 4 by itself? No. Can 7 go into 41 evenly? No. So we want to round it, and I'm going to look at those first 2 digits, and I'm going to round it in a way that doesn't apply to the rounding rules we just learned, right? It's not going to be the 5 or more or 4 or less. We're just rounding it to a number that 7 can go into. So what number close to 41 can 7 go into? Well, it can go into 42. So 7 goes into 42 6 times, and then 7 goes into 0 times, and 7 into 0 times. All right, so our estimate would be about 600. Again, we kind of broke our normal rounding rules because we wanted a number that 7 could go into evenly in order to estimate quickly, right? And mentally, ideally, right? Because that's the purpose of estimation. If you're going to sit there and struggle through the problem to just get an estimate, you might as well just solve it in the first place, right? You're kind of just making things more difficult for you. All right, the last thing we're going to talk about is front-end estimation. And this kind of, it's not, I feel like normal estimation is simpler than this, but this is more accurate. So if you need a more accurate estimate, but still a relatively quick answer compared to just solving it normally, then I would recommend front-end estimation. But if you're just like, I need to ballpark it, I need to just find where it's close to, then just do normal estimation. So front-end estimation is, you don't really apply these rules, right? What you really want to do is the 5 or more or the 4 or less doesn't apply. It's just use the highest digit. So that's going to be your first step. Use the highest digit to estimate. Right? To round. And everything behind it's going to be 0. So if it was 4,100 something, it would just be 4,000. But if it was 4,900 something, still just be 4,000. And I'll explain why in a second. Our next part is going to round. These are like 2 separate steps, right? So you're first going to do that and solve. And then from there, you're going to use the second highest digit to round and solve. And then you're going to combine the answers. And again, this sounds kind of confusing in me describing them, but I'll show you what it looks like in practice, right? That's why we have our examples to help us figure out what is trying to be said here, because it's something that needs to be shown more so than it needs to be explained. All right, so let's say I have a problem. I have 4,837 minus 2,152. All right, so step 1, I'm going to just take those highest digits. We have something in the 4,000s and something in the 2,000s, right? I'm going to ignore everything else about that number. Rounding rules are not applying here. 4,000 minus 2,000 is 2,000. Step number 2, let's look to the next section. We have our next digit is 8, is an 800, so we're going to put 800 as the number we rounded, and we have 152, so we're going to just round to 100. Again, those rounding rules are not applying. We're just taking that digit and putting the appropriate amount of zeros after it, and we get 700. Okay, and then we're going to round that again so it matches the top one. Round that up to the nearest thousands place. Okay, and so we'll do 2,000 plus 1,000. That's our final step. We took our two answers and we're going to combine them, and our estimate equals 3,000. Now again, I personally would choose the first type of estimation because I don't need it to be quite as particularly accurate, and I feel like these are additional unnecessary steps where you might as well just solve the problem. But this is another method that the curriculum wants us to learn about, and we may see problems about. And so that's what that looks like. So let me go ahead and hold this up. This is our last section in our notes. Okay. We won't see that as often, but I wanted us to be at least familiar with it. Last thing we're going to do is some guided practice. All right, this is from the workbook, page 27, 6 through 13, and 28, 16 through 19. So on page 27, it asks us to round to the nearest thousand. So I'm going to do 6, 7, 8, and 9 to start. So our first number is 6,321. The 6 is in the thousands place. To the right of it is a 3, 4 or less, let it rest. This is closer to 6,000 than it is to 7,000. Okay. Now remember, this is not part of our notes. This is just if we had been in class, this is what we would practice. We have 9,873. The 9 is in the thousands place. The 8 is behind it. 5 or more raise that score. That 9 becomes a 10. This number is closer to 10,000 than it is to 9,000. We rounded up. Next, we have 6,995. That is in the thousands place. To the right of it is a 9. And so 5 or more raise the score. That 6 is going to go up to a 7. It's closer to 7,000 than it is to 6,000. Next one, we have 12,051. Now, I have some students who always think, oh, I'm just rounding to the highest place value. No, it said round to the nearest thousands place. And in this number, 2 is in the thousands place, right? That 1, we're not even touching it. Okay, we're skipping it. 2 is in the thousands place. To its right is a 0. So 4 or less, let it rest. It's going to stay as a 2. That 1 we didn't touch, so we're going to leave that alone as well. But then everything else is going to go to 0. So it was closer to 12,000 than it was to 13,000. Okay, let's do one more set of these. Still rounding to the nearest thousands place. We have numbers 10, 11, 12, and 13. 65,500. The 5 is in the thousands place. To its right is a 5. 5 or more raise the score, so we're going to bump that up from 65 to 66,000. Next, we have 89,773. The 9 is in the thousands place. To the right of it is a 7. 5 or more raise the score. We're going to move that up from a 9 to a 10, but we can't have 10,000. That's not a number, right? That's nonsense, right? So we got to go from 89 up to 90. Right, next, we have 325,699. The 5 is in the thousands place. Behind it is a 6. Again, we're going to ignore those first two spots up front, and we are, because they're bigger than 1,000, but since that is a 6, that's 5 or more, we raise the score. We go from 325,000 to 326,000. And then finally, we have 600,039. That 0 is in the thousands place. To its right is another 0. So we're going to let it rest. We're going to keep it at 600,000. We're not going to bump it up to 601,000. All right, so that is our work for those problems. Okay. Moving on, we go to page 28, 16, 17, 18, and 19. We are going to round and estimate. So round and solve. So number 16, we have 7,192 plus 1,642. Those round to 7,000 and 2,000. So our estimate is going to be 9,000. Okay, so I rounded to the nearest thousand and then added. Moving on, we have 5,701 minus 3,214. Again, rounding to the nearest thousand. 5,701, that's closer to 6,000. 5 or more raise the score, right? That 7 bumps us up. Then 3,214, that's closer to 3,000 because of the 2. 6,000 minus 3,000 gives us 3,000. Okay, number 18. We have 3 numbers being added. We have 6,290 plus 5,500 plus 3,719. Round each of those to thousands, we get 6,000 and another 6,000 and 4,000. Add those all up and we get 16,000. That's our estimate. Last one. 9,810 minus 1,600 minus 7,391. Again, rounding those to thousands, we get 10,000 minus 2,000 minus 7,000. So 10 minus 2 is 8,000. 8,000 minus 7,000 gives us 1,000. There we go. So that's some practice with some estimation. Additional practice can be done with the Let's Practice section. That is more for teachers for other classes outside of mine, since I'm providing these lessons to use as a resource for some extra practice to check with their kids. I will be inserting practice problems into our Juno pod, probably from that section, but maybe some others, depending on how many questions I decide to use. So anyways, that is it for rounding and estimation.